calling all Globers. We need an answer on this Newton's bucket. Essentially, there's a difference between if there's two observers, one standing inside a bucket and one standing outside a bucket looking into it, and both observers are looking at each other at the start, right? If you rotate the first observer inside the bucket, or in another scenario, you rotate the guy looking into the bucket, in those two scenarios, they'll be exactly the same, except if you put water in the bucket. If you put water in the bucket and you rotate the bucket, the water will crawl up the walls of the bucket because of the centrifugal force. Essentially, it proves that there's not a dynamic equivalent between reference frames. I'm waiting for a book to address it, dude. Maybe I'm wrong. I mean, who knows? I
don't know what your full point is, but it's raining, so I can't Google this at the moment. Which one is the pseudo force, the transformable force between centrifugal and centripetal? Are they both pseudo forces? Are they both real forces? I thought one of them is transformable while the other is not.
Yeah, and then there's some sort of problem. Essentially, Einstein solves it by assuming that the stars in the background are indeed at rest. Which I don't know how you can say that, given if you choose another reference frame, they won't be at rest. So I'm not sure how that's supposed to solve any issues. And they're saying it indicates an absolute reference frame with the stars, which would make no sense because there's not supposed to be a absolute reference frame.
In relativity. Yeah, Mach. Right. That was
this has to do exactly with Mach's being principle.
Oh, Einstein was a proponent of Mach's principle for a little while, but he often changed his mind on that. He changed his viewpoint on it back and forth a lot. And at the point at which he had died in the 50s, he had denounced his support of Mach's principle at that point. But he did that a whole bunch of times where he'd go back to supporting it.
Because it's a problem.
Yes. So it brings up the question of an imperative operative definition of motion.
Yeah, Newton's bucket is a problem for relativity, and he struggled with it. He struggled with answering the bucket question. And he thought that Mach had a viable way of explaining how the bucket operates, and then he thought, no, that doesn't make any sense, and then he thought, yeah, it makes sense, and then he thought, no, it doesn't make any sense. And I'll tell you right now, it doesn't make any sense. If I go around a bucket, the water in the bucket will not start to spin. That's absolutely ridiculous. So then he's stuck with, well, the background stars have to be this special reference frame, which you can't make the stars a special reference frame, bro.
Well, Newton and Mach were not alive at the same time. Newton came hundreds of years before Mach. So he had and especially before Einstein, he had no knowledge of relativity or even Mach's principle with the fixed stars. Newton was
Einstein
the question at the time. The question at the time of Newton was about this operative definition of motion, like what can be done with electrical charges. And yeah, Mach had this idea of motion relative to the rest of the universe, as he called it, or the fixed stars, as it's been shorthanded. Yeah, and Einstein supported that at times, and then it supported at times, but relativity.
Yeah, but you're just repeating what I'm saying.
Relativity solved the problem of that by stating that the motion was relative, because the issue was there was no mechanism for how I could be moved, how the stars above me could be influencing that motion that I'm feeling right now. There was no mechanism for that, so there was an issue with Mach's view, and relativity solved that problem by making motion relative. It solved it by making motion velocity relative. Acceleration is still debated if that's relative or not, but it made velocity relative, and it made coordinate independent reference frames and stuff by using tensor formalisms and whatnot. And so it got rid of that whole question that they were asking.
But Einstein struggled with the problem.
Well, Einstein struggled with his acceptance of Mach's principle or not. And he struggled with it the same reason that modern day physicists and chemists and
So it's still a problem.
struggle with it.
So it's
Is
still
that how can the stars above me, by what mechanism can they be influencing, the physical way, the processes in reality, can they be influencing my motion on the earth, right? It doesn't make a lot of sense when you actually, it's a cute thing to think about in principle, but it doesn't make a lot of sense when it comes down to practicality. How are the stars and the planets and the heavenly bodies above me having an impact on my motion?
Right. So like I said, they say that the observer going around a bucket can cause water to crawl up the edge of a bucket. The same way as you spinning a bucket causes water to crawl up around the edge of a bucket. And they have a hard time in their mind accepting it or not because there's no evidence.
No. You have to distinguish. The bucket, Newton's bucket, is a question about an operative definition for motion, and Mach's principle is a different thing that can be used to try to give that definition, but they're two distinctly different things. Mach's principle is widely not accepted as being valid nowadays, whereas operative definitions, people are still trying to come up with those, but relativity answers that question.
By saying that the observer going around the bucket causes the water to crawl up the edges of the bucket is what they're saying, which Mach has a mechanism for.
No, it answers it by making velocity relative and potentially acceleration relative, where you can make coordinate independent reference frames and then use tensors to apply coordinates and transform between frames.
No, we're talking about a bucket with water in it and the water going to the edge of the bucket because the observer is circling the bucket. There's only two outcomes. Either the observer circles around the bucket and the water doesn't crawl up to the edge. Newton, what he said would happen. Or the observer circles around the bucket and the water somehow is affected by that and does crawl up on the edge. What the implications of what Einstein was saying. Maching principle being how that motion is translated from the observer going around the bucket. Both options are kind of bad because the first option just doesn't work with a heliocentric model. It just doesn't work. And the second of which is absurd, that me circling around a bucket would cause the water in the bucket to crawl up the walls of the bucket. That's absurd. So you have something that doesn't work with the modern day cosmology, or you have something that's ridiculous and not proven.
Yeah, I just haven't heard it framed that way. I've always heard it framed as a question about an operative definition of velocity or of motion, the change in your position vector. And that's answered in relativity by the ds squared value, which is Lorentz invariant, which means it stays the same no matter what frame you're taking to try to look at the bucket, whether you're moving with the water or you're outside of the whole thing, just looking at the water go around in the bucket. The time and space between those frames can change, but the summation or the integration of the both together is an invariant. It's a symmetrical value. It stays the same, and that answers the operative definition.